have to do is now we've seen them visually. In other words, I wanted you to have a concept of what this was visually first. Now we're going to have to interpret this with our functions, and we'll bring the calculus back into it. How will we know whether a given candidate is actually a relative max or min? So now we're back to talking about just relative extrema, relative local max or min. All right. So here's what they say in the blue box. Here's how I didn't have a chance to type it, so here's how I would kind of condense that. If f prime of x, the first derivative, okay, change the sign at c. And then when you're right before c, and when you're right after c, so this is in the little neighborhood of c, before c and after c. If f prime of x changes sign at c, if before c you've got it going at positive, that means it's increasing. If the first derivative is positive, it's increasing right before c, right? And if it's decreasing right after c, that means the first derivative is negative. So it's changing sign at c. What do you think c is? I was trying to make a little picture here by doing the up arrows and the down arrows. If it's increasing and then it's decreasing, it would be a relative max, wouldn't it? Can you see that? I mean, right before c it's going up, right after c it's going down. So we would have c is a relative max. Okay, that's what they're really saying. That's what they're saying in number 1. A little bit before c it's positive, a little bit after c it's negative, goes up, then goes down, it's a relative max. Okay? If we see it change sign at c, and before c it's negative, and after c it's positive, and we saw all this visually already, what do you think happens there? You got a relative minimum. C is a relative minimum. Actually, I should say f evaluated at c is a relative max or min. F evaluated at c is a relative min. It's going to occur at c, but the actual max or minimum value is the function's value at c. That's real important. So it's f evaluated at c is our relative max, and f evaluated at c is our relative min. Okay, does that help? I thought that may condense that a little bit. These are our candidates, our critical numbers or the endpoints. Exactly. Okay? And critical numbers are places where the first derivative either is 0 or does not exist. Right. Exactly. Now what happens if f prime of x does not change sign? So what do you see here? So in other words, oh, I don't want to do that. If before it's negative and after it's negative, before c it's negative, decreases. After c it's negative, decreases. It's not going to be. You're not going to have a relative max or min. And you can see that. You see that? Those pictures under no relative extrema in the gray box, in the tan box below that. So no relative extrema, maximum or minimum. Because if it decreases and it decreases some more, all it did was flatten out. It can still go, the tangent line can still go to 0, but it just flattened out. So that's why you see those two pictures. So what would that look like? That might look like a graph like this. Let me draw a little thumbnail sketch over here. Here's one that you know. Here's the cubing function. This is the graph of y equals x cubed. It has a critical value. Look at this tangent line. Look at that horizontal tangent right here. Does it flatten out right there? So it has a horizontal tangent at x equals 0. But it didn't change sign. The first derivative, the slopes don't change sign. The slopes are positive, the slopes are positive. It's increasing, it's increasing. All it did was it increased slower, then it started increasing again. It did do something. What did it do at x equals 0? Across the axis. Something about concavity? Now remember that? It changes concavity there, doesn't it? It changes from being concave down to concave up, point of inflection, but not a relative max or min. Okay, so we're trying to put all these things together about the features there. So we see here no relative max or min. But it's still a critical value. So it's a critical value is only a candidate to be a relative max or min. There's no guarantee that it actually is a relative max or min. You have to do this first derivative test. You have to look right before and right after to make sure you do get a sign change. All right, so let's go try a homework problem then. Finally getting to those, huh? So here we have a function. It's a fourth degree function. F of x equals x to the fourth minus 8x squared plus 9. And it says, find all x where the function has a relative extremum occurs, and then actually find the relative max or min value. Okay, so we got to find out the x value where it occurs first, and then find the relative max or min value. So in other words, let's go make a list for the candidates. Okay, let's look at our candidate list. In other words, I want to go over here and I want to make a list for all the possible x values that could be candidates for absolute max or min. And then I'll have to go find out what their f of x values are. So how am I going to get the candidates? Well, our candidates would be critical values or endpoints. Now this doesn't have any endpoints because it's what's the domain for this function. Did they tell me any restrictions on this function? They just gave me the function, didn't they? They just said, here's my function. In other words, I don't say x is equal to some other, x can only start at 0 and end at 5. It's just left it open. It's on an open interval. Here the domain is all real numbers, so there aren't any endpoints here. But sometimes there are, so we have to keep that in mind as we go through this process, that our candidates would be critical values or endpoints. Okay, well, how are we going to find critical values? First derivative equals 0, or first derivative does not exist. Well, okay, let's go do the first derivative. That'll be something that you'll breathe easy with, right? 4x cubed minus 16x. That's our first derivative. Okay, set it equal to 0. All right. So if the first derivative is set equal to 0, then I can factor out x, and it's going to give me x squared minus 1 equals 0. So I've got x equals 0, and then x squared minus 1 equals 0. That's x equals plus or minus 1. Because if I take the square root, or I could factor that. Would y'all rather factor more? It just depends on how you see how to solve each of these. You have this many factors. This 4 can't be equal to 0. X can be equal to 0, or x squared minus 1 can be equal to 0. And then that's x squared equals 1, which is x is plus or minus 1. Are you not following me? Because you can factor this too into x plus 1 times x minus 1 and set each of those factors equal to 0, and you get the same numbers. So our candidate list would be 0, positive 1, negative 1. Is there any place where the first derivative does not exist?
Now what did it be? 4x, I'm sorry.
Okay.
4x, x squared minus 4.
Oh gosh, that's why you guys are looking at me. Yes, yes, yes. I'm so sorry. Okay. Oh my gosh. Can't factor. Okay, I'm sorry. That was a goof, yes. I knew there was I could sense that. That's because I goofed. And I wasn't paying attention to that. How about this? I'll do it this way. I'm correcting my mistake. Sorry. All right, so now what are our critical values? 0, plus 2, and negative 2. Better? Okay. Now I'm recorded forever, having made a goof.
I'm writing in pen.
And you're writing in pen, oh no! Oh no. Okay. Is everybody clear why that the first derivative is still a polynomial? It's still not, there's no place where it's not going to exist. So, I mean, here's our first derivative. The domain, I can still insert all real numbers in here. I don't have anything over 0. You know, I mean, anything where I would be dividing by 0, would I have to worry about that? So, there's no sharp corners on this. All right. So these are my only candidates. All right. Elvia, yes, ma'am. Okay, why is 0 candidate? Well, it is actually a factor here. When I look at this factor here, because I could factor out 4x, right? So, in other words, I could set this factor, I'd set this factor equal to 0, I get -2. If I set this factor equal to 0, I get x equal +2. If I set this factor equal to 0, you can think of it as like 4x equal to 0, divide both sides by 4, x could equal to 0. In other words, just look at it back like this. If I plug in x equals 0, I got 4 times 0 minus 16 times 0 is still 0. So that's another x value for which f prime of x is actually going to be equal to 0. Okay, so that's what we see happen there. Okay. So, now, here's what we have to do. Here's our candidates. We can evaluate the function at all these, but we still don't really know what's happening next door. Do we really know? These are just candidates. We don't know for sure that these are actually max or mins until we see the first derivatives change sign. So we're going to do a sign chart, just like we did for increasing, decreasing. All right? So let's go along here. And so we've got 0, -2, +2, and we're looking at the sign of the first derivative. The first derivative sign. What is that going to give us? You know, when we're behind -2, let's see if we can figure it out. Let's see. So what number do you want to use behind -2? -3? -3 maybe? Okay, so what is f prime evaluated at -3? That's 4 times -3 quantity cubed, which would be 4 times a -64. So that's going to be, I'm going to run out of space. Will y'all do it on your calculator for me? Let's do it on our calculators.
So you're plugging 1 into 1.
Okay, I got to find out what's happening out here before -2. To the left, a little bit to the left of -2. So I'm going to try -3.
And you're putting that into where?
Into the first derivative. Because I got to know what the sign of the first derivative is. That's what my first derivative test tells me. I got to know what the sign of the first derivative is in order to know whether it's a max or min. So let's see. We're going to get -3 cubed. Did I say 64? Yes. Sorry about that. Okay, plus 48. -60.
-60.
So we get -60. Most importantly, it is negative. So it's negative out there. It's negative everywhere in that interval. All right. Now I got to find out what happens between here and here. So draw, not only put the little negatives, but draw your little down arrow. That will help. So it's going to, in other words, the first derivative is negative. It's decreasing on that interval. Okay. How about 1? Negative also. Oh, how about -1? Sorry, because that's going from left to right. So how about -1? Does that -1 will be actually a positive value. It comes out to be positive 12. So it's positive. So it's going up there. Okay. And then it's going to be going down again. Because if we try 1, f prime evaluated at 1 comes out to be a -12. So it's negative. So it's going down again. My function is decreasing. The first derivative is negative. The function is decreasing. And then after 2, it's increasing again, isn't it? Because f evaluated at, the first derivative evaluated at 3 comes out to be 27 minus 16. 108 minus 48, which is positive 60. Right. All right. So we get that. Okay. Now we know, because of our first derivative test, we know. All right. We know some things now. We know some things about the relative extrema. We don't know the values yet. So these are candidates. Now the candidates are all actually relative max or min. So let's go find these values first, and then we'll label them over here on the other side as relative max or min. Okay. If x is 0, now you've got to go back to the original function and evaluate. Okay? To fill these in. This is the original function. If I know that x is 0, what's the value of the original function? 9. Right. If I plugged it into f of x. If x are 2, I've got to evaluate the original function. So 2 to the 4th minus 8 times 2 squared plus 9. 16 minus 32. Yep, negative 7. So negative 16 plus 9 would be negative 7. Okay, I agree with that. And if it were negative 2, it's going to be the same, isn't it? Sure enough. Okay. So now let's classify them. Over here in red. Do I have any room to write this? All right. This first one, at x equals 0, go back to your little sign diagram and decide it goes from increasing to decreasing. What is that? If it goes increasing to decreasing, keep a visual. Yeah, see? If you draw those little arrows, look at how it helps you. See it. Increasing, decreasing, increasing, decreasing. So, I didn't label them in the same order I've got them. So, for 0, 0 is a relative maximum. Relative maximum occurs at 0. The relative maximum value is 9. Okay? How about this one? How about at 2? It goes from decreasing to increasing. That's a relative min. All right. And how about at negative 2? It's also another relative minimum. Because look at negative 2. At negative 2, you go from decreasing to increasing. So, because we knew that right before it, the sign was negative, right after it, the sign was positive. Elvia? Well, now it's true what this is. This is static. This is the value of the function. This says, Elvia's question was, she was looking at these things and wondering about the signs changing. Well, this is different. This is imagine the graph. Okay? On the graph, you're going to have the point 2, negative 7. So we should even maybe do a little thumbnail. Maybe that would help. So 2, negative 7. 2, negative 7. 2, 3, 4, 5, 6, 7. Right here. Okay? Right before it, it's decreasing. Right after it, it's increasing. That's the sign change. The sign change is occurring in the first derivative right around it. Okay? So right here in the first derivative, see, it's decreasing, then it's increasing. That's what we found out from this information here. And over here, this is the point, negative 2, negative 7. So that's this point. And it has the same little thing right there, decreasing, then increasing. But then at 0, it's way up here at 9. So it's going to have to look something like this. And we got our relative maximum there. Okay, so, I don't know, I messed that up. Did that help? Okay. So when we're talking about changing signs, we're talking about the first derivative, what it does right before each of those candidates. But the outputs of the function are the maximum or minimum values. So in other words, this is a relative max that occurs at 0, and the relative maximum value is 9. Okay? And here a relative minimum occurs at 2, and the minimum value is negative 7. So that's how to understand that information here, this information here. For candidate lists, now we put them down and we find out that, aha, sure enough, this is my maximum value. These are my minimum values.
Would the absolute value be negative 70?
Well, yes, because this thing can only turn at those three places. Those are the only critical values. That's the only place where the first derivative is 0. So now I can kind of extrapolate the rest of the graph. Yes, it'd be increasing on either end. That is not only relative minimums at 2 and negative 2, it's also the absolute minimum at 2 and negative 2.
There's no absolute maximum.
Right. That is true. That is true. Okay. So what shall we do for homework then? Absolutely. Absolutely. Oh no, I know. I just lost it. I just went forward. Okay. Well, because now the domain was never, they never said the domain had to only be between negative 2 and positive 2. It changed, the first derivative changes sign at negative 2 and positive 2, and now those are the only critical values, those three critical values. So now we know that it actually has to be decreasing from negative infinity up to negative 2. So I know it has to come down like that. And then it has to, and then it's increasing from 2 to positive infinity. So I know it has to go up like that. Right, exactly. Right. Okay.